Hello wonderful person, this is Anton, and in this video we're going to be talking about ice ages. And more specifically, a recent study that may have actually answered the question of what seems to be causing the ice ages on our planet. And to begin, we need to define what ice age even means. And that's because some of the modern movies and some of the modern media unfortunately made us a little bit confused about what ice age really is. Now technically, we're still in the ice age. And generally speaking, ice age simply means that Earth at some point somewhere on the surface has ice shelves. And we do have ice shelves in the north and in the south of our planet. So this is why technically we're still in the ice age. And this period actually began approximately 2.6 million years ago, when for still unknown reasons, the surface of our planet that you see right here started to drop in temperature, eventually letting various ice shelves to develop on the surface. Now this is kind of what it actually looked like approximately 2.5 million years ago, and this period is essentially defined by these glacial and interglacial periods when there is more ice, or the ice retreats and suddenly disappears and the planet becomes a little bit warmer. Now currently we are in the middle of the so-called interglacial period, and this interglacial period began approximately 12,000 years ago, and before that we were in the middle of the glacial period where there was a lot more ice everywhere. And although the scientists currently do believe that we're headed toward another glacial period where the planet should technically be cooling down, because of various climatic changes, well technically because of all of the gas we've been releasing, the planet is actually warming up. In other words, we are prolonging the interglacial period and are possibly even causing what's known as a greenhouse period, which is when the planet becomes even warmer than before. Now these periods have happened before, and one of the more known examples may have occurred on our planet approximately 150 million years ago, and the reason why it occurred was because there was a huge release of methane, which in 2012 scientists discovered may have been caused by the dinosaurs, which may have been just as guilty as the humans in creating a greenhouse effect, although obviously not through the release of CO2 but through the release of methane by eating a lot of food that produced a lot of gas. However, we're not as interested in the dinosaur era as we are in our modern era in trying to understand what's actually causing these glacial periods in the current ice age. And mostly because we have no idea what started it, and we have no idea why these glacial and interglacial periods happen. We do have some clues, and more specifically clues in regards to so-called Milankovitch cycles, which do seem to correspond to interglacial periods in regards to various cycles our planet goes through. For example, the cycles of change in eccentricity because of the way the planet orbits around the sun, the changes in obliquity, which essentially changes the tilt of our planet, and lastly, the so-called axial precession or wobble. Now all three do produce really complex Milankovitch cycles, which are more or less kind of difficult to actually predict. But at the same time, there could be a much simpler answer. And so a lot of scientists out there have been trying to find, is there an easier way to explain these cycles, and is there a way for us to somehow predict when the possible next glacial period begins? Now, the study that you can find in the description below does pretty much that. They decided to take a look at various geological features such as stalagmites from Italy and combine them with some of the other evidence coming from sediments in Portugal. And by essentially combining the two elements, they were able to much more accurately predict the temperatures from the past million or so years. And the stalagmites here were used only for one reason: to fill in the gaps that were missing from other records. So for example, the ocean records from Portugal were not actually enough to produce the entire timeline. But by combining both of them, they were able to see very accurately what the actual temperature differences on our planet were throughout the last million years. And what this allowed them to see is that approximately 960,000, but also 870,000 years ago, the planet undergone the so-called warming period, or more accurately, the so-called Age of Termination. Now, these periods seem to actually perfectly align with this right here, planetary obliquity. And more specifically, both of those ages occurred when the planet had the highest inclination. Now you may already know something about obliquity, but in general, the reason our planet wobbles like this is because of the interaction with other gravitational bodies in the solar system, such as for example Jupiter. But the thing is, the moon, as it orbits around the planet, actually stabilizes the tilt of our planet. If the moon was not present, our planet would be wobbling a lot more unpredictably and very likely up to about 90 degrees. But it doesn't do that. It only stays between approximately 22.5 and about 24.5 degrees. And as you can see, currently we are right here somewhere in the middle, but it's slowly dropping. Eventually though, it's going to go up again. But the drop here, the next drop, is not going to lead to the major glaciation period. However, this drop here in approximately 100,000 years will. But before this major drop, we're also going to have a major high, which will probably create a very warm period on our planet in about 80,000 years from now. And obviously changes in eccentricity and axial precession probably matter as well, but it seems that the major component when it comes to interglacial and glacial periods, or basically ice ages, is this. Now, it kind of makes sense too. During the higher tilt, a lot of the sunlight will be striking north of the planet and essentially preventing ice from forming here. And even though the southern hemisphere may actually receive less sunlight and end up a little bit cooler, because there is going to be no ice whatsoever in the north, where usually we do have really large ice sheets, overall this will probably warm up the planet, giving it a lot more oceans in the north, and thus producing a lot of warm currents that will probably also warm up the south. Because for the most part, our planet is really good at circulating the heat around. But at the same time, when the planet decreases its tilt down to 22.5, or even, as you can see here, 22.1 degrees, this may suddenly start the opposite effect. The ice formation in the north will very likely increase the albedo of the planet, allowing for more light to be reflected from the surface, cooling down the north, and thus also causing the south to cool down as well, creating larger and larger ice sheets all over the planet, leading to another glacial period. Now obviously this is a much simpler explanation than what's really happening here, because there are probably a lot of other effects such as release of different gases as the ice melts, release of things like CO2 and methane, and the other effect that's being ignored here is the weight of the sheets. When these ice sheets disappear, they will very likely dislodge a lot of the crust underneath and maybe even produce additional volcanic eruptions, which thus release even more gas. So it's more of a really complex cycle that's caused by the actual tilt of the planet. But at the same time, there could be some other effects that we're not thinking of. Although nevertheless, what this paper shows is that a lot of this temperature change does seem to correlate with one major component that's easy to calculate: the axial tilt of our planet. Now, as I mentioned before, we're not really too worried about this part, which will happen in about a few thousand years from now. But these two events, in about 80,000 and also in about 100,000 years, may actually dramatically change the planet once again. And in case you were curious, in the next 17,000 years or so, the obliquity of our planet is actually going to drop by about 1 degree, being around here. So in the next 17,000 years, the planet is expected to be a little bit cooler on average. But with the human effects and a lot of other things that are happening on the planet, we're technically actually reversing this, making it go up instead of going down. We're not entirely sure what this is going to cause to the planet just yet, but historically speaking, the dinosaur age, which was also extremely warm in comparison to what we have today, may be a really good case study for us to try to understand what happens when extreme levels of greenhouse gases end up being released into the atmosphere. But anyway, that's kind of all I wanted to mention in this video, mostly because it's an interesting discovery, but it does need to have follow-ups, and we need to learn a little bit more about how the climate changes with the tilt of our planet from some of the other sources as well. For now, all we can do is wait for more studies and more discoveries in regards to climate change and in regards to planetary changes as well. Hello wonderful person, this is Anton, and in the last 2 years we've been able to discover life in some of the more remote and more hostile places on the planet. But in this video we're going to be talking about this new discovery where we found life where we really didn't expect any. In the last 3 or 4 years, scientists discovered some of the more extreme life in some of the most extreme conditions on the planet. And some of these discoveries were quite mind-blowing. For example, approximately a year and a half ago, the scientists were able to discover quite a lot of life inside the Earth itself, essentially in the depths of the ground underneath our feet. And some of this life was thriving there. When the scientists tried to calculate how much of actual bacterial biomass was present in the Earth itself, and this is essentially including parts of Earth approximately 5 kilometers below the surface, they realized that there was approximately 300 times more of bacteria inside Earth than the total mass of all of the humans combined. So basically, a lot of new biomass was discovered in locations where we really didn't think anything could survive. As a matter of fact, of all of the investigations we've taken so far, it seems that only one place on Earth has not really yielded any life. And I've actually mentioned this in one of the previous videos as well, but the most hostile environment on the planet seems to be this unusual volcano in Ethiopia, which I've covered in a lot of detail in the video you can find popping up above my head near the end of this video. Here, the conditions were just too acidic, too hot, and too extreme for even the most resilient life to survive, but only one of these volcanic lakes was uninhabited. Everything else, however, did have at least some life. But the scientists, whose paper you can find in the description below, got really lucky and they got to use this incredible research ship known as JOIDES Resolution, which is essentially a science platform. It's a science drilling platform that has been used since 1978 for various types of underwater research. Just like every other drilling platform, which usually are responsible for discovering all kinds of oil and gas deposits underneath the ocean, this drill is also capable of going under the ocean into the ocean floor and drilling a few kilometers into it. And for this study, these scientists were able to get approximately 750 meters below the ocean floor, into the location where some of the actual crust was already partially molten and basically was pretty inhospitable to anything you could imagine. But as you can probably tell from the title of the video, once again we were able to discover life there as well. Now this is a really interesting discovery because in this particular location really no one expected to find anything. Because not only is the environment completely inhospitable, but there's not much to basically eat there. None of the bacteria would actually have any sources of energy and would most likely just perish over time. But it turns out that there are at least two types of bacteria that were able to survive in these regions. The first was the extremophile bacteria known as Crucocidiopsis, which is usually able to survive in some of the most hostile conditions, including high acidity, high temperature, and so on. And we've even been able to establish that this bacteria could be perfect for us to take to Mars because it can actually easily photosynthesize in very inhospitable environments and create oxygen out of red light or even far red light, allowing us to grow oxygen and possibly even food from just a few small samples of this bacteria. We've also discovered the so-called Pseudomonas bacteria, which is able to convert a lot of different things into energy. And this bacteria is unfortunately one of those bacteria that occasionally also turns into a parasite, causing problems for humans and a lot of other animals. But it also happened to live really deep in the ocean underneath the crust. And the bacteria deep down there was actually able to either produce their own food from just a small amount of various organic molecules, or some of them were found a way to generate energy out of the actual minerals that were present deep down in the ocean. Now, there were not a lot of these bacteria. As a matter of fact, the scientists estimate that the actual density is really low, meaning that there's approximately 2,000 or so bacteria per cubic centimeter, which is only about this big. But nevertheless, this already means that life can actually live in really weird conditions on planet Earth. And a lot of these bacteria were able to very effectively recycle and store all kinds of materials to be able to survive deep down there where nothing else can. And it seems that some of them were even able to survive on just a few partial amounts of organic matter that would seep through the cracks into the deep part of the oceanic crust. Now, not all of the bacteria needed that organic matter though. Some of it was actually surviving on some other materials that were already present. Which is of course great news for us if we were to try to discover life somewhere else in the solar system, such as for example Enceladus, the moon of Saturn that does seem to contain very similar conditions to what we've discovered in a lot of other parts of our planet. Just like so many other moons of other gas giants such as Titan, Ganymede, Io and so on, a lot of these moons do seem to contain conditions that could easily support extremophile life coming from planet Earth. In other words, if I were to take one of these bacteria we found and then put them somewhere on this moon, possibly inside the moon actually, they would thrive there. They would survive with absolutely no problems. Or at least that's what we believe. It's very possible there's already a lot of life on those moons and we might even discover it in the next decade or so. But for now, discovering these extremophiles in these very inhospitable conditions has actually been only more support for the so-called existence of extraterrestrial life. Because obviously, if life can survive here, it will probably be able to survive on a lot of other objects in the solar system and possibly even other exoplanets out there in our galaxy, the Milky Way. Now personally, I still think that the best chance for us to find something is going to be right here on Titan, the other moon of Saturn. But until we actually launch the mission called Dragonfly in the next few years, we're not going to be able to know anything about this beautiful moon. Although in about 5 years or so, I might be talking about the discovery of life here after all, because this right now is the best source of unusual methane variation and a lot of other signs that suggest that something is causing the atmosphere of this object to change. And that something is probably bacterial life. Hello wonderful person, this is Anton, and today we're going to be talking about the hottest planet in the solar system, Venus. But more specifically, we're going to discuss the possibility of life here, especially based on some of the more recent studies. So imagine an object that is so extremely hot, acidic, and filled with so much pressure that even the toughest Soviet probe only survived here for like 2 hours max. As a matter of fact, that probe was able to take a picture that sort of looks like this after processing. So this is Venus, the hell of the solar system. How could we talk about life possibly existing here? Well, when the Soviets discovered that the temperatures and pressures and the acidity here was just too extreme, they more or less abandoned further missions. They realized that no life will probably be found here. But in 1963, Carl Sagan wrote a very interesting paper proposing that even though on the surface of Venus there might be no life, we could potentially find something in Venusian atmosphere. And he even identified a region in the Venusian atmosphere that is currently referred to as the habitable zone of Venus. This habitable zone is anywhere between 47 to about 70 kilometers of altitude, and essentially it's the region where we can technically expect temperatures and pressures very similar to those right here on Earth. Anywhere between -20 to about 65 degrees Celsius, with pressures of about 1 atmospheric pressure, and the only problem being, well, a lot of acidic clouds more specifically. But that never really stopped some of the bacteria here on Earth. As a matter of fact, in one of the recent videos I talked about the extreme waters and lakes of Dahlul's volcano, which have some of the highest acidity possible actually. It's basically pH of 0 and very high temperatures and also a lot of acidity. And many lakes here do have life. Some don't, but many do. And this suggests that some of the more extreme bacteria could technically survive in those upper layers of Venusian atmosphere. And the thing is, there are a lot of signs pointing at some unusual, strange activity in the Venusian atmosphere. More specifically, we have recently discovered what seems to be climatic changes, or basically something equivalent to, I guess, seasons of Venusian atmosphere, where the temperature and also, most importantly, these unusual patches do change in size depending on the year. And today many scientists actually think that the unusual dark patches that have been observed inside the atmosphere, or the so-called dark UV absorbers as they're also known, could maybe be caused by some sort of a bacterial organism that is absorbing the UV light and is using it for its life purposes. In other words, there is currently a lot of scientists believing that Venusian life could actually exist in the upper atmosphere. Now, this would not really be a surprise because we do have bacteria living in our atmosphere and even upper atmosphere. While at the same time, even though technically Venus currently looks like this is a composite shot taken by the Venera missions back in the 70s. Once upon a time, we think Venus looked very much like Earth. It had oceans, it had very likely a lot of atmosphere, possibly oxygen, and for all we know it may have had life. And if some of that life survived, it could now be thriving in the Venusian upper atmosphere. And so the most recent study assumed that there could be life here and decided to investigate if it can survive other dangerous to life phenomena, such as, for example, the cosmic rays that strike Earth and of course Venus from every single direction. So we know that cosmic rays and radiation can easily destroy life, and because it comes not just from the sun but also from the actual space around us, it could destroy any life that is trying to survive in Venusian atmosphere if there's a lot of radiation there. But because Venus has such a thick atmosphere and because it's so close to the sun, it generates this unusual phenomenon known as the induced magnetosphere, sort of by accident. Basically, when the solar wind, because of its power close to the sun, strikes Venusian thick atmosphere, it creates charged particles which then cause Venus to have a little bit of magnetosphere, but possibly enough to protect some of the life if it exists in the atmosphere. And so the scientists behind this recent paper that you can find in the description below decided to investigate, assuming that life is in the atmosphere, would it survive the radiation? And they decided to look at bacteria such as this bacteria right here, which survives in really extreme environments. This bacteria is known as Shevonella oneadensis, and it's very interesting to science because it doesn't seem to need oxygen or a lot of other materials to survive. It can thrive in metallic or sulfur-rich environments, and it can also even help us extract some of the metals if we ever decide to go and explore other worlds. But the most interesting part about it here is that it could easily survive in the conditions of the so-called habitable zone in Venusian atmosphere. The only other danger to this bacteria would be radiation coming from cosmic rays. And if it can technically survive the cosmic rays, there would be almost no reason for us to assume that something in Venusian atmosphere could destroy bacterial life. And by analyzing various conditions and various doses of radiation, the scientists behind this paper basically came to a conclusion that there is not enough radiation in the Venusian habitable zone to harm Shevonella oneadensis. In other words, most bacteria similar to this one would easily survive in Venusian atmosphere, and despite acidic clouds, would very likely thrive in those conditions. There's a lot of material there, there's a lot of sulfur, there's a lot of what would be equivalent to bacterial food, and any bacteria that's present in the atmosphere of Venus could definitely adapt to these conditions and even use the UV light coming from the sun for its own purposes, which is maybe what we're observing with these strange unexplained UV dark patches that scientists have been witnessing in the last few years. So far there's really no explanation, no chemical explanation for what we're observing, but many scientists believe that maybe a bacterial colony of an extremely large size could explain what we're seeing. Essentially Venusian life, but not on the surface, in the clouds. And interestingly, the Venera missions and also the Magellan and Pioneer missions that came to Venus roughly around 40 years ago discovered a lot of interesting materials here that are used by life here on Earth. For example, the Magellan mission discovered different types of carbonyl sulfides. We also discovered a lot of hydrogen sulfides, sulfur dioxide, and all of these materials are used here on Earth by life to produce energy. And so there's no reason for us to believe that Venus is incapable of also hosting life, but slightly different from life on Earth. Now, unfortunately, no major mission is really being planned to Venus anytime soon, and the only currently functioning probe around Venus is the Japanese Akatsuki that is currently mapping and exploring the Venusian atmosphere in a little bit more detail. It's also trying to discover any kind of sign of lightning, for example, and hasn't really seen anything. It seems like there's no lightning on Venus. But anyway, that's something we'll talk about in some of the future videos. What is important though is that we don't have any missions planned to try to discover if what we're seeing on Venus is life. Because there might be alien life very close to Earth, the closest planet to Earth, Venus. But currently we're really just planning missions to Mars and not Venus. Although interestingly, last year NASA awarded about $120,000 to one of the teams to try to develop something similar to what you see on the screen. A kind of an autonomous flying drone that would stay in the atmosphere and try to discover something alive. But the thing is, this is still in really early planning stages, so it would probably be at least a decade before we develop anything equivalent to an actual mission. For now, we only have Akatsuki and its beautiful pictures. But anyway, what's important from all of these studies is that there are clear signs that something is going on in the atmosphere of Venus, and all of these signs point at bacterial life. Unusual life that seems to affect the atmospheric conditions on Venus and also seem to visually change the appearance. And if we're lucky, in the next few years, we might discover what exactly is causing this. But until then, that is all I wanted to mention in this video. Let's finish this video on this beautiful image of so-called Mount Mons, the 8-kilometer high volcano, the image for which was created by the Magellan mission many decades ago. Hello wonderful person, this is Anton, and in this video we're going to be talking about a newly discovered crater that was created by a collision with a relatively large rock approximately 800,000 years ago. So collisions with meteorites and various types of rocks and of course comets are pretty common here on the planet. But the thing is, Even though quite a lot of different rocks do enter our atmosphere pretty much every single minute here on the planet, and we often even see them as the streaks of light known as the shooting stars, we were once again reminded by how dangerous these rocks can be back in 2013 when the so-called Chelyabinsk meteorite entered our planet and caused a relatively destructive explosion in the air above the city of Chelyabinsk. NASA even has this beautiful map that it created of all of the various collisions that happened in the last 25 years, many of which were so powerful that you could technically call them nuclear bombs. They were actually even more powerful than the bombs dropped on Japan. But luckily for us, none of these occurred over cities, and most of them were either in remote areas around oceans or in places where nobody really lives, and so in that sense they're not really that dangerous. But since this is all related to statistics, eventually one of these rocks will definitely hit somewhere where people do live. Which is why it's important for us to understand when collisions occur, how they occur, and how to prevent them from happening. So in the last year or so, actually just over a year ago, NASA scientists discovered two really large, really major craters in Greenland. Both of them were hidden behind the ice. These two craters were created by rocks that were roughly around 1 kilometer or even more than 1 kilometer in size, and most of this was a result of a very large collision, very likely within the last few million years. The larger crater is estimated to be no older than 3 million years, and some people even suggested that it could be approximately several thousand years. And some scientists even suggested that one of these craters could be responsible for the mystery of the so-called Younger Dryas cooling period. This refers to this unusual cooling period around 13,000 years ago that we still can't really explain very well. But none of this is conclusive yet. But nevertheless, it's very important for us to understand how often these asteroids do collide with our planet, and how likely are we to see something like this happening in our lifetime. In other words, these are really important studies in order for us to protect our civilization, our way of life, and of course other life on the planet. Which is why it's so important for us to look around for the history of these craters and these collisions. And very recently, the international team from Southeast Asia released this amazing paper describing what they believe yet another crater that was created by a relatively large rock that hit our planet approximately 790,000 years ago. They currently believe the location of this crater is right here in Southeast Asia, around the region of Laos, and it's actually hidden underneath the so-called Bolivian Plateau volcanic field. In other words, it was kind of invisible and still is invisible. So for example, if you were to go there right now, you're not going to actually see a very large crater that would be neither easily visible nor actually exposed for us to study the actual age of the crater. But to support this idea and this theory, the scientists actually proposed 4 major pieces of evidence identifying exactly why they believe the crater is there and why they believe this corresponds to the collision 790,000 years ago. So first of all, this is what this area looks like on Google Maps, and you'll notice right away that it does actually have this unusual roundish shape, surrounded by these unusual formations very similar to mountainous ranges that become even more apparent if you look on Google Maps using an actual satellite map. This so-called Bolivian Plateau or Bolivian volcanic range in southern Laos looks like an extremely beautiful place to visit and seems to possess quite a lot of rainforest and a lot of various waterfalls. So by just going there, you're not going to actually know that you are inside the crater. So how did these scientists find out that something like this did happen approximately 790,000 years ago? Well, first of all, they were able to identify quite a lot of different tektites, these remains from a collision, spread across a very large area, even finding them as far as Antarctica, in Australia and other regions in Southeast Asia, and all of these pieces were actually dated around the same time. This alone actually led the scientists to start investigating what could have possibly caused such a tremendously powerful collision, because here it's as if something collided somewhere here and then spread a lot of particles across a very large part of our planet. We can actually even simulate this in Universe Sandbox by essentially taking a rock that's approximately 1 kilometer in diameter and then launching it toward the region where we think it collided. So here, let's actually see if it creates a very similar effects and spreads a lot of material across the planet. So here, if it collides under a certain angle, you'll notice that pieces will start flying toward the other regions of the planet. But I don't think I actually collided it fast enough and under a necessary angle to create what we're observing here in real life. So basically it probably came from a very inclined angle and was moving relatively fast, so this was a very powerful collision. But the way that the scientists discovered the actual region is by looking around and finding out that a lot of these tektites were actually located not so far from this region here, and it had a lot of these deposits spread across a very large area near the Bolivian volcanoes. And on top of this whole area is actually covered in what's known as basaltic rock, which can often be an indication and a telltale sign that some sort of an impact did occur. And at the same time, when they actually dated these rocks, when they tried to identify the actual age of the rock, they discovered that there was a dramatic change in the way that lava was flowing around 790,000 years ago in this specific region, which sort of suggested that something major must have happened here for the lava to actually start flowing differently. But they've also identified a major gravity anomaly in that specific region by looking at the gravity maps around the area, and they discovered that something unusual must have happened in that region for the gravity anomaly to be formed the way that it was shaped. Now, Earth has a lot of gravity anomalies, and there's actually quite a lot of them that are still unexplained, but that one specifically seemed to have indicated that something major occurred in the region. And then lastly, they also saw a bunch of unusual boulders kind of tossed around the area about 10 to 20 kilometers away from the region where they were originally created, and it's as if something just picked them up and threw them elsewhere around the area that's right here. This can only be done either if something major explodes in this area, or if I guess someone just picks them up and brings them there. But because of the way that they were deposited, the only logical explanation is that there was a large collision and very likely a very large explosion that caused all of these boulders to kind of move away from the place of origin. In other words, all of these four signs indicated that there was a large major collision with a rock about 1 kilometer in diameter that created a really explosive event that very likely changed our planet. But how? And that's where we kind of actually don't have an answer. We still don't really truly understand how these collisions affect our planet. For example, some scientists today believe that a collision would usually lower the temperature of our planet for at least a few decades and possibly even a few hundred years. This is kind of what the theory of Younger Dryas tries to prove by identifying the collision with a large asteroid that may have happened 13,000 years ago, but there are still a lot of signs suggesting that maybe this wasn't a collision at all. There is still no definitive proof that a collision of this proportions caused this unusual effect. So in that sense, we still don't really understand how collisions with asteroids affect our planet. We know that it was very destructive, it obviously killed all of the life in this region, and very likely did change the planet in some way. We're just not entirely sure why. But because I was so curious, I actually wanted to investigate whether any dramatic changes in temperature around this period according to our knowledge of the history of our planet. Now, first of all, how do we even know the temperature back then? Well, pretty much all of our studies on temperature of our planet are based on what's known as ice cores, and these are essentially kind of like long tubes of ice that are extracted from within the depths of ice of Antarctica or Greenland, and are then thoroughly studied by scientists by identifying certain features that can indicate what the temperature was in that period on our planet. And so by using ice cores, the scientists were able to identify what the temperature of the planet was in the last few million years. And if you look right here, this is kind of the graph that shows you what's going on here. So first of all, as you can see right here, these are a prediction of what might happen if the global warming continues. But if you look at the region that's approximately 790,000 years ago, there was an unusual warming, but then a sudden cooling as well. So we don't really know if this here is in any way related to the asteroid collision. And the thing is, if it is related, if this is actually what this asteroid caused, then it's quite possible that all of these other indicators here are also somehow related to collisions as well. And this right now is probably one of the more important studies that we can undertake to try to identify how our climate changes if a collision occurs. Now remember, I mentioned that we've discovered at least 3 major collisions in the last year or so, and all 3 occurred within about this period of time here, or possibly even way before that. So we know that one happened here, one of them might have happened here as well, and both of these collisions were quite explosive and quite dramatic. If it actually hit Southeast Asia today, this whole region here in Southeast Asia, and very likely even much larger part of the planet, would be greatly affected. This would very likely result in hundreds of millions of people dying and possibly even cause a dramatic shift of civilization as we know it. And the modern predictions suggest that a similar collision with a rock of about 1 kilometer that would create a crater that's about 14 kilometers in size would actually happen approximately every 440,000 years. In other words, there might have been another one that happened about 400,000 years ago, and scarily enough, there may even be another one happening in the near future. And this is definitely something we need to investigate a little bit more, because in the last few years we've identified a few of these large rocks that are these so-called near-Earth asteroids. And by the way, this crater here is roughly around 15 kilometers in size, which might also suggest that the rock was even larger than 1 kilometer, and very likely produced the total explosive power equivalent to about 1,000 Tsar bombas. Now, Tsar Bomba is the most powerful hydrogen bomb ever created and exploded on our planet. It was roughly around 50 megatons. And just to give you an idea of how powerful it is, here's actually a really cool simulation from the website known as outrider.org that shows you what happens if you drop a bomb on a certain location around the world. So here, if we choose New York, because I guess why not? And I really hope I don't actually get tagged as some sort of a terrorist because of this. But anyway, so if we choose a Tsar Bomba, notice how it actually creates such a dramatic explosion that it pretty much destroys most of the city and creates a huge fireball that you can see right here that essentially incinerates everything within a radius of about 5 kilometers. Now imagine something that's even 1,000 times more powerful suddenly coming and creating all of this energy in the same spot. Unfortunately, this simulation doesn't allow us to go that far, but I think you can kind of use your imagination and try to estimate what something that's about 1,000 times more powerful will create. And this is of course why such studies are really important in helping us understand how this might actually affect our planet, but more importantly, how often these occur, and how to eventually find a way to redirect these asteroids by basically somehow changing their orbits and shifting them away from their collision course with our planet. So this is something that modern science is very busy at trying to establish, and hopefully within the next few years we'll have not just the technique for how to redirect the asteroids, but also how to possibly use these redirect techniques to find a way to either mine the asteroids or even terraform planets like Mars. Hello wonderful person, this is Anton, and in this video we're going to be talking about a very interesting discovery that was made only a few weeks ago that suggests that a large collision with an asteroid or possibly a comet may have actually afflicted really early human settlements and possibly even completely destroyed one of the very famous early human settlements in Syria. And specifically, this may have happened around 13,000 years ago, giving one more piece of evidence to a potential impact that may have happened around that time. This discovery and a lot of other similar discoveries relate to something known as Younger Dryas impact hypothesis, which is essentially an idea that someone proposed a few decades ago, that there was a very large collision with our planet, and something along the lines of a large comet or a large asteroid decided to strike our planet and caused a major shift in climate for approximately 1,000 years. Now, this idea has not really been accepted by everyone, and there's a lot of actual counter evidence suggesting that something else may have happened to our planet. But because there's really so much to cover, you can actually check out more about this by yourself by using the link in the description. In short, the Younger Dryas refers to this period right here that lasted for approximately 1,000 years and started around 13,000 years ago and then ended just as abruptly as it started. It actually followed a very warm period during which a very important human culture known as Natufians became quite widespread in this region of the Middle East, and more specifically today we're talking about this right here, the city known as Abu Huraira. And here's one of the pictures taken by one of the scientists a long time ago, and essentially this site is what seems to be the first location for the humans, at least for these specific humans, to go from being hunter-gatherers to becoming more agriculturally oriented. And all of this actually did happen during this transition of Younger Dryas. So this is something really important in terms of human history and in terms of understanding our own evolution. And most of the evidence of this impact is actually from discovering these unusual black mats that seems to date around 13,000 years ago, suggesting a potential collision and an asteroid or a comet that sort of deposited this layer across our planet. It's been discovered in several different locations. Most recently, last year, we discovered it in South America and Chile, and along with some of the other pieces of evidence, like for example different types of rare unique metals, or for example this right here, melt glass spherules, which only form during really cataclysmic events such as for example collisions, lightning strikes, or even volcanic eruptions, seem to indicate that something cataclysmic did happen in those specific regions. And the other piece of evidence comes from the sudden disappearance of megafauna, very large animals that used to be everywhere and suddenly disappeared over the period of a few thousand years, most likely due to some kind of a climatic change. And although disappearing animals and layers that we've discovered could be also explained by individual collisions, they don't have to actually come from a massive strike from a very large comet, certain scientists like James Cannett essentially spend their whole lives trying to see if this hypothesis can be turned into a theory and become reality. Now this is sort of how we discovered that the dinosaurs were wiped out by an asteroid and not really volcanoes or any other events. A few decades ago this was also just a hypothesis, but when we found the crater in Mexico that was dated around the same time as the disappearance of dinosaurs, this really made it pretty clear. At the same time, we still don't really have a good crater here. We don't really know if anything did hit our planet approximately 13,000 years ago, but there are signs that something may have actually done it. And the biggest proof could actually come from right here in Greenland. A few months ago, actually more like a year ago, I've talked about the discovery of a very unusual crater in Greenland that seems to suggest a relatively recent collision, but right now we don't really know when it happened. If this did indeed happen approximately 13,000 years ago, then this is definitely a hypothesis becoming a theory, and we definitely had an impact around that time. But it will probably take a few more years before we can discover how ancient this crater is, and more specifically, if this is indeed connected to all of those other events we've discovered. But what exactly did scientists discover just now? Well, it seems that whatever happened in the location known as Abu Huraira approximately 12.8 thousand years ago was very likely an extremely large impact, raising temperatures to about 2200 degrees Celsius and practically wiping out the settlement that used to be there. Now what's really interesting is that one thing we know about Abu Huraira so far is that it's a settlement that actually came in two different stages. The first settlers here were hunter-gatherers, and they essentially lived and were quite successful right around this time. When the climate changed, the disappearance was very sudden, and then they reappeared again as a second settlement, but this time turning into an agricultural society and essentially showing us some of the first signs of actual crops being raised. And one of the reasons I actually took this paper very seriously right away is because of the main author, Andrew Moore. Because he's the major archaeologist who discovered Abu Huraira and who essentially excavated and collected all of these samples from there back in the 70s. Since then, the Syrian government unfortunately turned the site into a lake, so all of this is now underwater and is going to be really difficult to study. But the scientists behind the study have collected enough evidence back in the 70s to actually be able to analyze all of the samples, and what they've discovered in them are unusual melt glass formations, specifically the type of melt glass that usually forms during cataclysmic events. And as always, they've also discovered signs of metals that normally come from various space bodies such as asteroids and comets, and a lot of other additions and inclusions inside various samples, all of which suggested space origins. And in a nutshell, what all of this of course suggested is that approximately 12.8 thousand years ago, this is very likely what people living in Abu Huraira experienced. But this was not a giant impact, not an impact that would create a crater similar to the one in Greenland that's 30 kilometers across. This was a much smaller collision, probably even an air boloid of some sorts that exploded in the atmosphere. So technically this could be a completely unrelated event and very likely just an asteroid or a comet that destroyed the settlement. However, when they started comparing the samples to the ones in Chile and some of the other regions, there was actually a little bit of similarity, and this suggested that maybe they are connected after all. Now, what does this mean? Well, for one, this does add a lot of credibility to the impact idea, that maybe there was an impact and maybe this did change the climate of our planet. However, this also decreases the chance of this impact being an actual large massive rock, because even the scientists themselves suggested that it wasn't really a large impact that would cause a large crater like the one we've discovered in Greenland. It's actually very likely something completely different. It's possible that what this was is maybe something similar to what you're about to witness here, although maybe on a slightly smaller scale. a collision of a comet or an asteroid that fell apart and essentially collided across our planet in various locations around the same time. And this multi-collision event is why we can't really seem to find a large crater, yet we're finding the actual signs and basically the indications of various collisions across various regions, including places like Chile, places like Arizona, and now Middle East. Now, does this mean that somehow this impact changed our culture and essentially changed the evolution of humanity? Well, it might have. But right now we don't have enough evidence. We just know that this particular settlement very likely did experience some sort of a major cataclysmic event that transformed it to being something completely different, specifically an agricultural society in essentially a few hundred years. But we have no evidence of this event wiping out the megafauna, and we have no evidence of this event changing the actual climate of the planet just yet. We just know that there was a collision in this region that probably destroyed the settlement and very likely destroyed a large part of the community here, but it definitely did not actually affect Natufian culture to that extreme, which lasted for at least a few thousand years after that. For example, we did discover other Natufian houses around the region that were actually dated a lot later than that, and also various types of pottery that was already being generated in this region, and this was after the so-called Younger Dryas event. And although this particular discovery doesn't necessarily answer the Younger Dryas hypothesis and doesn't explain what happened back then, it does suggest that something cataclysmic may have happened after all. Anyway, this paper is actually really good, and I do recommend that you give it a read because it does explain a lot of things that I didn't cover in the video. You can discover this paper in the description below, and you can also find out more about the settlement and also the Younger Dryas impact hypothesis in some of the other articles I'm posting in the description. On that note, once we learn more about what happened to our planet back then and why the climate changed so much, I'll make sure to follow this up with another video. For now, it's a really cool discovery. And interestingly, that's actually not the first time we've learned that a settlement has been destroyed by a comet or an asteroid. And I'll make sure to follow this up with a video where I explain what else happened a few thousand years ago. Hello wonderful person, this is Anton, and in this video we're going to be talking about the new discovery of a very interesting crater in Australia known as the Yaraba Crater that seems to have been created right around the time when the Earth went from being a frozen snowball, the period known as the Snowball Earth, to the liquid wonderland that we know today. In other words, this was the period when it's very likely the asteroid actually thawed or melted the entire planet. Now, it's actually kind of shocking how many different collisions our planet received, but it only becomes apparent when you really look at our neighbor, the moon. Every collision on the moon, after it happens, it stays there because there's no plate tectonics, there's no actual geological activity, so everything that happened in the last few billion years is visible to us. Earth, on the other hand, does have geological activity, so only a few craters remain here, and only some very large craters survive to this day. Now, the largest crater to date, and actually the previous record holder for the oldest crater discovered, is located in South Africa right here, and I'm actually going to make a separate video about this crater in near future. But the so-called Vretta Crater that you see right here, this is a picture taken from space, was created around 2 billion years ago from a collision with a rock that was about 10 to maybe 15 kilometers in size. And that's almost double the size of a rock from Mexico, the Yucatan Peninsula, that was responsible for the extinction of the dinosaurs. So in other words, these rocks and all of these craters that were created on our planet are actually created by relatively similar in size objects. Some slightly larger than others, but for the most part, none of them are like in hundreds of kilometers in size. They're usually anywhere from 1 kilometer to maybe about 10. But the real surprise came from this region right here in Western Australia, the area known as Yaraba. And it doesn't really even look like a typical crater, to be honest, but it is there nevertheless, and the scientists knew about it for a very long time. The thing is, they never really bothered to measure how old this place really is. But some scientists were really curious, and specifically the scientists behind this paper in Nature that decided to investigate what's really happening here. And to everyone's surprise, they've discovered a really large object underneath all of these layers of rock. And this crater that was created by a collision is roughly around 70 kilometers in diameter, suggesting that the actual piece of rock that collided with our planet was very likely just a little bit smaller than the asteroid that collided with our planet when the dinosaurs perished. So in other words, it could have been about 3 to 4 kilometers in size. But honestly, this shouldn't really surprise us, because Australia in general is a great place to look for historical events. The entire area here is literally like a preservation site. Many things here, when they happen, remain untouched and completely undisturbed for millions and even billions of years. So in that sense, we're definitely going to be discovering even more interesting things in this region. But how exactly did the scientists find out how old this area is? Well, today, for the most part, when it comes to trying to figure out how old certain rocks are, we use a very interesting technique known as uranium-lead dating. The way that it works in principle is, let's just say I found a meteorite somewhere in Australia. I want to find out how old this is. I take a small sample of this rock and I measure how much of uranium-235 compared to lead there is in this sample. And the reason why I'm measuring uranium and lead is because all of the uranium-235 will eventually slowly transform into its final component, which is lead-207. Approximately half of all uranium will convert into lead in about 4.5 billion years. So if I discover something that has an equal amount of uranium and lead in it, it's very likely about 4.5 billion years old. If I find that there's a little bit more uranium, it means it's a little bit younger. If there's more lead, it's a little bit older. But the thing is, when there is a certain event, like for example a very energetic asteroid impact, it's going to generate so much energy underneath it that all of the uranium will actually get reset. So now the geological clock has restarted and you can kind of start counting from zero again. And so if we find a sample and we measure its uranium to lead content, we'll be able to identify how old certain material is. And in case of Yaraba area, the samples were about 2.3 billion years old, 2.229 more specifically. And surprisingly, this date is somewhat meaningful to us, at least in terms of historical events that happened to our planet. It just so happens that around 2.4 billion years ago, our Earth experienced a major transformation. A few years ago, I even made a video about this, describing exactly how our Earth looked back then. It was very likely purple, and you can find out why in the video right there somewhere above my head. But in a nutshell, a new type of bacteria started to appear on Earth and became extremely successful, and that bacteria was able to produce a lot of oxygen. We refer to this event as the Great Oxygenation Event, when basically the entire planet started to become covered in oxygen. Before this, it didn't actually have that much. And this oxygenation event very likely killed off most of the other bacteria on the planet because oxygen is actually somewhat toxic, especially in large quantities. So in that sense, this event transformed our planet, and first it removed the older life, but then it also turned the planet much cooler, simply because there was just not as much greenhouse effect anymore. And eventually the entire planet froze over. Although it's quite possible that certain parts of the planet were still kind of more or less open, and there was a little bit of liquid water showing in certain parts. But the vast majority of the planet was very likely covered in ice. And one of the reasons we know that this happened is because when we look at really ancient Earth by looking at various sedimental deposits of our planet, we actually discovered that there were certain periods when even in the tropics there was actually quite a lot of ice, and more specifically we see these signs of different glaciers moving around and disturbing the ground underneath. The only explanation to having ice in the tropics is if the entire planet was basically frozen. There's really no other simple explanation here. And furthermore, we actually think that this happened twice. First time about 2.4 to 2.1 billion years ago, and second time right before the very complex multicellular life exploded on our planet, the period we refer to as the Cambrian Explosion. And I've also talked about this concept in one of the previous videos in a little bit more detail. And so if our planet was an ice bowl at least twice in history, something must have happened to the planet in order to turn this into this. Something must have melted all of the ice, or at least started the melting process. Now, we always suspected volcanoes, but there's really no way for us to prove that this was a volcano. But we also know that if an asteroid hits the planet, that essentially all froze over, there is a chance that it can pierce through the actual ice shelf and release so much of various materials, and more specifically water vapor, that's a very strong greenhouse gas, that can cover the whole planet and dramatically increase temperatures pretty much overnight. Well, at least in a few years. And this could definitely kickstart a new sort of melting, a new thawing of the planet, and restart the planetary cycle. But why talk about it when we can actually demonstrate it? So here comes an asteroid, that will hopefully help us simulate all of this using Universe Sandbox. So once it collides with our planet, it should open up at least a part of it, melting some of the material here. We'll probably have to wait a little bit for this to happen, but eventually you'll see that there is an area here that becomes exposed. This could be the initial area where the melting occurs. At the same time, this collision itself, because of all of the greenhouse gases that were released, is going to start melting ice all over the planet, and you're going to see this any second now. As our whole planet starts transforming relatively slowly, but within about a year, it's going to become basically like the Earth we know today. So all of this may have, or very likely have, started as a result of this collision, and the fact that the date of this collision remarkably seems to actually correspond to the end of the glaciation period, or the end of the so-called Snowball Earth, is quite unlikely to be just a coincidence. So there might be a relation between these two events. Now, of course, because this is science, we'll need to confirm and reconfirm this, and a lot of other signs need to be discovered before we can confirm that this is exactly what happened. But this first study is an amazing first step in trying to help us understand how Earth went from being a completely frozen over world with life only surviving underneath the ice caps into the beautiful world that we know today. And this is also something that we need to understand if one of these collisions one day happen around objects like Europa or Enceladus that are essentially ice worlds just like our planet once was. And so once we understand how these massive collisions affect our planet and how they affect other planets and other moons, we'll be able to understand how all of this helped our planet evolve, and most importantly, how the life became so complex and if it can happen somewhere else. Hello wonderful person, this is Anton and this is our planet Earth. Today, the single day on our planet takes approximately 24 hours, but in the past it was actually much shorter. We've known about this for quite a while, but the new evidence suggests that right before the dinosaurs went extinct, approximately 70 million years ago, the single Earth day was about 23.5 hours. You might have already heard that at some point in the past, Earth was actually spinning much faster. As a matter of fact, approximately 4 to 3 billion years ago, a single day on our planet was probably around 6 hours or so. Now, we don't have the exact evidence just yet, and we don't really know exactly how long the Earth day was, mostly because we don't have any samples to prove that the Earth day was that short. But we do have samples, including the more recently discovered one, to show us that the Earth day did actually slow down over time. Now, first of all, why is it that the Earth rotation is slowing down and is actually going to be even slower in the future? Well, to answer this, we have to add another object, the Moon. As you may already know, the Moon is tidally locked to our planet, meaning that this will always face the planet and the other side will always be invisible to us. And this is essentially how all of the bodies want to spin around one another, because this allows us for the most efficient energy transfer. Our planet, however, is not tidally locked, because it's more massive, approximately 81.3 times more massive. And because of this mass difference, it will actually take Earth a lot longer to reach the so-called tidal lock. We believe that it might actually never even happen because the Moon is slowly moving away from our planet. And all of this is actually connected. So because the Moon is kind of trying to slow down our planet, it's trying to tidally lock our planet to itself as well, it's basically causing the tidal effects to slow down the rotation of the Earth. And as this happens, the energy from the rotation of our planet is being slowly transferred to the Moon. And this causes the Moon to actually slowly move farther and farther away. The current estimates suggest that the Moon is moving away from Earth approximately 3.8 centimeters per year, or about 1.5 inches. And so eventually it might even completely disappear from the orbit of the planet and become its own object. But that's not really the point of the video. The point is that Earth is slowing down. And although we knew about this theoretically and from some of the other samples, it's always good to have even more proof of this unusual feature. And the new proof comes from this right here. This is the sample of so-called rudist clam, which is actually an extinct species that existed and thrived in the age of the dinosaurs. It was one of the more successful species in the water. And rudists back then actually were responsible for producing most of the corals. And you might know already that corals and coral reefs, at least today, are exceptionally important for the marine ecology and for the survival of various species. Today, corals are produced by what's known as coral polyps, which are kind of like jellyfish, except that in reverse, and they are related to jellyfish, which existed for many millions of years as well. But when the dinosaurs were around, corals were predominantly made by the rudists, and these rudists were really good at it. And because of this, we've discovered quite a lot of various samples around the planet, giving us a lot of opportunities to study these rudists in a lot of detail. And all sorts of different rudists existed back then, varying in their shape, varying in size, and also in what they were doing on the ocean floor. But this specific rudists were really good at growing their shells, and especially good at doing so during the daytime. So by measuring the actual length of the rings inside the shell, we can kind of calculate how many days this particular shell was growing, and easily determine which ring represents daylight and which represents nighttime. And by using an extremely accurate count using lasers, these scientists behind this paper were able to calculate precisely how many rings this particular rudist was able to create during its lifetime of about 9 years. And they were able to find out that a single year here lasted for about 372 days, as opposed to 365 as it is today. Suggesting, of course, that Earth back then was spinning a little bit faster by about half an hour per day. But this is really not the most part of this discovery, because studying rudists in general allows us to understand how these types of creatures evolve, and more specifically how they influence the ecology of the oceans and transform the actual life of other organisms. Rudists, as I mentioned, were really important because they also created corals. But they actually seem to have started going extinct even before the dinosaurs. And there's even evidence that a lot of rudists went extinct even before the asteroid strike that sort of finished off the dinosaurs. And so it seems that the oceans were warming up and changing, and this warmth may have actually caused the extinction of rudists way before the asteroid strike. Now, you might already know where I'm going with this, because there is a very similar parallel happening today. We are witnessing the disappearance of coral as it may have disappeared back then as well. The warming of the oceans today is unfortunately decreasing the size of the corals in Australia, in the Caribbean, and in a lot of other regions. And a lot of these events related to corals are unfortunately happening a little bit too fast. And today we're still trying to investigate what's really causing this so-called coral bleaching, but pretty much everywhere around the world, this has been slowly turning into this. And it really seems to be connected to the warming of the oceans around the world, which also seems to be exactly the same reason why rudists went extinct as well. But obviously it's too early to make these connections because a lot more studies are needed. For now, what is interesting here is that corals, in general as a concept, seem to have found a way to return after millions of years and are created by completely different organisms from before. So what used to be produced by rudists is now produced by these little guys, which are more closely related to jellyfish. And that's actually the good news here, because it does seem like life finds a way to recover and to return to what it used to produce, but in slightly different ways. And because rudists were so common back then, I'm sure at some point we're going to learn a lot more about the oceans back then, and hopefully try to understand what really happened to the dinosaurs and all of the other creatures during that period, because modern scientists today don't think that asteroid strike alone killed all of the dinosaurs and all of the other life that went extinct. They believe that this was the last straw, basically the last little piece that essentially caused the mass extinction. But there are signs showing today that a lot of the life was already going extinct even before this occurred. And this is probably one of the more important things we can kind of try to understand today. And the reason we'd like to learn more about it is because I guess in some sense we're hoping that we are currently not causing another extinction event, even though a lot of signs do seem to be pointing that way. But anyway, the most important part of this video is of course evidence of the rotation of the planet that changed over time. And even though about 70 million years ago Earth was spinning about half an hour earlier, when the complex life appeared on the planet and when it started spreading across the planet, the Earth day was about 21 hours. So back then days were much shorter. And one of the mysteries today is to try to find out how all of this affected the evolution of life and how all of this may have changed the planet or even affected the climate here as well, because quicker days may have meant warmer temperatures. But this is not something we can definitely answer right now. Hello wonderful person, this is Anton, and today we're going to be talking about the magnetic field of our planet. because of all things that make our planet exceptionally majestic and very unusual, and also of all things that allow our planet to support life, the magnetic field is probably one of the most crucial ones. So when it comes to the terrestrial planets of our solar system, it's really two that actually possess any kind of magnetic field. This one here, Mercury, has a very weak but still functional magnetic field, and of course our planet Earth that still has a relatively powerful field around it. Mars unfortunately no longer possesses anything, and today we believe that it's one of the reasons why it lost its atmosphere and is no longer able to support liquid water, even though at some point in the past it probably had a very large ocean. Venus, on the other hand, is even more unusual in that it doesn't really produce the magnetic field the usual way, but it does possess something known as the induced magnetic field that's created by the highly energetic particles that strike upper atmosphere and then generate a type of a weak magnetic field around the planet, although it's not even remotely comparable to what our planet has. In other words, when it comes to magnetic fields, our planet definitely wins, and we think it's why it still has liquid water and why it's able to support life. And even though some of the more recent studies discovered that our magnetic field is actually a lot older than we originally believed, possibly as old as the planet itself, about 4.2 billion years old, we are still not entirely clear at, first of all, how it's generated, even though there are a lot of different ideas and theories, and second of all, how it changed throughout the history of our planet. And that's of course until some of the recent studies, including the recent major study that you can find in the description below. So today we believe that the reason we have the magnetic field is because of the so-called liquid outer core that's churning and moving around in the fashion that you see right here. This is actually one of the more recent simulations created by the scientists. And we believe this motion is caused by the central inner solid core that's so hot and so dramatically different in temperature that it forces the outer core to circulate in this fashion. And because the material here is metallic, the circulation then creates the magnetic lines that we're observing. In other words, even though the idea is sort of simple in principle, when you really look at what's happening here and try to simulate all of this on a supercomputer, the actual reality is quite dramatically more complex than we ever thought. So this is kind of one of the recent simulations, and it shows you how extremely complex all of this is. But the thing is, this is only the more recent development in the history of our planet, because we believe that all of this started about 540 million years ago. Now, this date is actually a little bit more significant than some people think. 540 million years ago is also the beginning of the so-called Cambrian Explosion that saw the development of some of the more diverse and some of the more complex life ever. Basically, this was when a lot of various multicellular animals started to be created, and they spread all over the world and allowed the evolution to really kickstart. Basically, this is when life as we know it kind of began. Before that, it was a lot more simple and usually either unicellular, or if it was multicellular, it was a lot more primitive. But whether it's connected to the creation of the magnetic field, we don't really know. And also, until very recently, we didn't even know if there was a strong magnetic field before this. As a matter of fact, scientists didn't actually think it was that strong to begin with, and this kind of conflicted with the idea of magnetic field protecting our planet. And so the recent study that just came out discovered that, well, apparently the magnetic field in the past was even stronger than today. And this illustration here with the dates on the bottom, this is in millions of years, so basically this here is about 4.2 billion years ago, this here is about 3 billion years ago, shows you how it compares to the more recent values. You'll notice how about 3.2 billion years ago the magnetic field was basically close to double the strength. But if the weird, strange churning mechanism was not actually working yet, how is that even possible? And also, how do we even know there was magnetic field to begin with? Well, for this particular study, these scientists used really tiny rocks, very ancient rocks from Australia known as zircon. These rocks are actually used in a lot of different applications, but for this particular study they wanted to find some of the oldest rocks on the planet, and it just so happens that Australia is really rich in these different deposits. As a matter of fact, there are several areas that you can see right here that have some of the most ancient rocks and zircon rocks that we've ever seen anywhere on the planet. A few years ago, this for example made the headlines because this was the oldest rock discovered at 4.4 billion years old, and this was from Australia as well. But why these rocks? Well, inside of these rocks they actually do contain metallic materials, and more specifically, some of these minerals contain metallic materials on the inside that actually becomes trapped in time as the zircon solidifies. In other words, if there's any kind of metal in there and it's sort of exposed to the magnetic field, as these materials are formed, the metal will actually form in a certain direction. But to help you understand this a little bit better, one of the best examples I can give you is actually from the ocean floor. Today, if you look at the ocean floor, in certain parts of the world you'll discover where the tectonic plates are actually sort of moving apart from one another. And it just so happens that if you were to analyze the actual formations of rock as it slowly moves away from each other, you'll discover that once in a while there's these magnetic stripes. Basically, some of the material in the rock is deposited this way, north to south, and sometimes it's deposited the opposite way, south to north. And this is actually exactly how the scientists discovered that, well, apparently, the magnetic field of our planet actually flips once in a while. And by using these strips, because they actually move away with a certain period of time, we can then calculate how long it takes for the magnetic field of our planet to flip from north to south. And so using a very similar analysis, the scientists were able to use these rocks to essentially discover that the magnetic field of our planet was much stronger in the past. And this required them to actually do a little bit of analysis, because they needed to figure out how was it actually formed. What created this magnetic field if the so-called geodynamo, basically when all of this stuff is churning inside our planet and generating the magnetic field, was not actually active yet. Something else must have been creating the magnetic field, and that something they believe was magnesium oxide. And the actual story goes as follows. So approximately 4.4, maybe 4.5 billion years ago, there was a very large collision between planet Earth and a Mars-like object known as Theia. This, we believe, created the moon and possibly created a lot of other conditions on our planet that allowed our planet to evolve into what it is today. But at the same time, this also created a very unusual deposits on the surface of various materials, including the relatively magnetic material known as magnesium oxide. Although I think this is a more unusual picture of the magnesium oxide. This is the 3D dice that the scientists created a few years ago. A much more common picture makes it look more like a powder that you would find inside a typical bottle. And so because of this collision, the scientists think that a lot of magnesium oxide ended up in the inner parts of our planet. But with time, the magnesium oxide within our planet started to precipitate out and move slower and slower toward the surface. But because it's magnetic, the actual motion of magnesium oxide from inside to the outside of the planet continuously generated a very powerful magnetic field around the planet for a few billion years. But eventually the planet ran out of magnesium oxide on the inside, and so it's quite possible that the entire magnetic field actually disappeared for at least some time, although we don't really have any evidence of this just yet. But luckily for our planet, approximately 540 to maybe 565 million years ago, another mechanism started the magnetic field, creating the dynamo that we have today. And this is something that will last for at least a billion years from now. Now, we're not entirely sure what started this, and we're also not entirely sure how long our planet was barren and basically was without the magnetic field, or if this period even existed. But we think that it was actually because the inner core of our planet formed. Before that, there was really nothing, it was more of a liquid core. And as soon as the inner core became differentiated from the outer core, there was a kind of a temperature barrier that then started generating all of these cycles that you see right here. Before that, we don't think it existed. Now, once again, the mystery here is that, is this related to the sudden explosion of life? There is a correlation, but we don't really know if they're connected in a direct way. It's very possible that because this was now available and before that there was almost no magnetosphere, life could now actually become more active and even live on land as opposed to just in the water. But once again, a lot more research is needed to see if this is connected. And the other mystery we have is in regards to other planets. Did they also have a very similar magnesium-based magnetic field, or did it work in some other way in the past? For example, how exactly did this work on Mars? Now, this is something we can only solve by going to Mars and studying the rocks in more detail, but until then, it's going to remain mystery. But nevertheless, discovering how the magnetic field works and how it survives on some planets but not others is exceptionally important in our search for the next planet we could potentially settle, or a planet where we could find life. Today we are absolutely certain that the magnetic field is one of the major reasons why our planet, okay, maybe not this destroyed planet, but the planet that we all know and love, was able to maintain life for so long, and how it allowed life to evolve here. Magnetic field is literally a shield that protects us from a lot of things out there in space. Without it, we're not going to survive for very long. So finding objects with magnetic field and understanding how it works is really important. Hello wonderful person, this is Anton, and in this video we're going to be talking about a discovery of what seems to be yet another miniature moon of our planet Earth. And at the same time, this object also seems to be the smallest discovered so far. Now when we talk about moons, it's actually kind of difficult to really define what a moon is. So for example, when we look at our own moon, it is very different from moons of Jupiter and Saturn. And even though the size and the mass of moons of Jupiter are somewhat similar to the moon that we have, their origins and also their composition are extremely different. Our moon is actually a lot more similar to so-called Charon, the partner of the beautiful Pluto that you can see right there behind it. So in this sense, there is actually no true definition to what a moon is, but normally we define moons as satellites of planets. And here is roughly what this would look like in Universe Sandbox. So as you can see, the moon is obviously orbiting around planet Earth. But we also have these so-called quasi-satellites or temporary moons. As a matter of fact, there's quite a lot of them. One of these objects, known as 2016 H03, is right here. We've discovered this back in 2016, and as you can see, it does seem to appear as if it's orbiting our planet, and is thus known as a quasi-satellite. But it's not going to be doing this forever, because it's actually simply orbiting the sun, but once in a while comes close enough to planet Earth that it does appear to have an orbit around it. And China is even planning a mission to this object. In 2024, they're thinking of trying to retrieve a few samples and returning them back to Earth. A few other quasi-moons have even stranger orbits, so this one right here, as you can see, is following the yellow path, and it's technically also a quasi-moon. But none of these are stable orbits, and at some point they'll actually either completely move into a different part of the solar system, or will probably disappear altogether by crashing into something. And so it shouldn't really be a surprise that we've discovered yet another one of these rocks in a somewhat quasi-permanent orbit around the planet. It's been here since 2018 at least, and it's actually really small, possibly as small as 1 meter or approximately 3 feet across. And this rock was only discovered very recently, only in February of 2020, using the telescopes from the so-called Mount Lemmon Observatory in Arizona. It's currently designated as 2020 CD3, and it does have this very peculiar and somewhat chaotic orbit, as you can see right here. And this orbit suggests to us that this object is probably only going to stay here for maybe a few more months, possibly a year, but we don't really know what's going to happen to it afterwards yet. And this is actually the second such object discovered, the so-called temporary quasi-satellite. First one was discovered in 2006, and it did actually approach Earth several times. Here's what the orbit of this object looked like back in the 90s, and as you can see, it approached Earth sometimes a little bit too close, sometimes a little bit farther away, and continued doing so until eventually it got kicked out of the system because of the interaction with the moon as well. Now, these objects are really interesting because, first of all, well, these are really ancient samples from the beginning of the solar system. These are basically asteroids that were created really early. And because they do come so close to planet Earth, it's quite possible for us to try to capture one day. At the same time, these objects help us understand how our moon influences the orbits of these different asteroids, and thus presents an opportunity for us to study orbital interactions and how the moon protects Earth from various asteroids. And even though the object 2020 CD3 has been with us for about 2 years now, it might already actually be on the way out. And because this is the smallest object discovered so far with a size of only a few feet, this really gives you an idea of how good we became at detecting these asteroids orbiting around the planet, or possibly approaching and maybe even colliding with the planet. So we're definitely getting much better at detecting asteroids that could be very dangerous, and also actually finding ways to redirect them as well. There are a few studies that came out recently that have established really interesting techniques at how we could potentially redirect asteroids by calculating their orbits years ahead and then slightly nudging them with a small rocket in order for them to actually go somewhere else. But as I mentioned previously, it's still somewhat challenging for us to define what an actual moon is. Now, for example, when it comes to different objects in the similar orbit around the sun, there are a few more locations, like these Lagrange points right here, that can potentially possess actual permanent objects. We usually refer to these objects orbiting in this region as Trojans. The most famous Trojans are all located in the orbit of Jupiter because it's the most massive planet and it's able to maintain their orbital parameters much better. But here you'll see that there are quite a lot of these Trojans in both of these Lagrange point locations. And some of them we're actually going to be investigating with some of the future NASA missions, but Earth also has at least one Trojan we're aware of. The object known as 2010 TK7. This object is actually really large. It's approximately 300 meters or about 1,000 feet in size, and if this were to collide with Earth, well, let's just say it would probably cause major destruction and a lot of climatic changes. But the question here becomes, does this also constitute a kind of a moon? Because technically, this is what its orbit looks like around planet Earth. It does increase and decrease in size quite dramatically, and it's more or less permanent because of the location known as the Lagrange point. And if so, this would definitely make this the second permanent moon around Earth. Likewise, only about 2 years ago, we've discovered that in the same points, the L4 and L5 Lagrange points, there are these so-called Kordylewski clouds. These are essentially collections of smaller rocks and a lot of various dust that is visible from planet Earth, and in some sense is also representative of what's happening around the Trojan points of Jupiter. Would we also call this some sort of a satellite as well? First, this would imply that there are possibly a lot more of these objects in these regions that we haven't discovered yet, and second, this would also imply that we have this unusual dust cloud in orbit around planet Earth. Not really a ring, but not really an asteroid either. So this could be a completely new phenomenon, and possibly all of the other planets have them as well. Kordylewski clouds have actually been named so-called hidden Earth moons, so in some sense some scientists do actually believe that we should be naming these moons as well. And what this of course suggests is that there are just a lot of different quasi-satellites and a lot of different satellites in general. So the definition for the moon that we have right now, or definition of moons in general, is just not really well defined. We definitely need to reassess on what exactly do we mean when we say a moon of a planet, and we also need to redefine what exactly all of these other objects are, because calling them quasi-satellites is not particularly exciting. And interestingly, every time we discover these objects, they usually come up in the media as the so-called second moon of Earth, because it really feels like these are moons, but at the same time, we just don't really have a better way of calling them yet. And one of the reasons why we don't have a better definition for them is because we don't really know where they came from. If their origin is somehow related to what happened to Earth in the past, then maybe these are moons of Earth. But if these are just asteroids that got captured by Earth, then, well, they're technically just passerbys. Travelers going around the solar system creating these beautiful patterns, but they're probably going to at some point go somewhere else. Hello wonderful person, this is Anton, and in this video we're going to be talking about a new discovery that suggests that at some point our planet Earth was actually extremely different from what it is today. More specifically, as the title says, it may have been a water world, with the global ocean being so large that there were probably no continents and only a few very small islands. So what we've learned about our planet in the last few decades is that it's gone through a lot of different stages and evolutions. And I don't mean just the visual changes of, for example, how the continents changed. So for example, approximately 800 million years ago, our planet Earth was probably a little bit more similar to this, but it still had a global ocean, and it probably still had a lot of different continents as well, although those continents very likely did not have much life on the surface. This is a simulation made by Ian Webster, and the link for this is in the description below. But there are obviously a lot of other phases that our planet had. At some point, our planet went through a few so-called ice bowl stages when it was essentially a very large ball of ice, or at least resembled something with a lot of ice on the surface. And we also believe billions of years ago Earth was also very likely purple, mostly because of the type of life present in the oceans that very likely turned the water purple. But you can also learn more about the purple Earth and the ice bowl Earth theories in some of the previous videos. Today we're talking about another discovery. The discovery that suggests Earth was actually a very large water world, somewhat reminiscent to that movie with Kevin Costner that was made almost 30 years ago and essentially was called Waterworld. Now, interestingly, this paper published very recently discusses just that. As a matter of fact, they find very unique evidence that suggests that approximately 3.2 billion years ago, Earth was actually a water world. Although this is still only the first discovery, so this needs to be confirmed by other scientists. But essentially, this is what the scientists here discovered. Like a lot of other really interesting discoveries, all of this started in Australia. Specifically in the northwest part, that has a lot of different areas that have been preserved for billions of years. And in one of these areas of Australian outback, the scientists discovered that there's actually a very unique hydrothermal system that's been preserved for just over 3 billion years. They've discovered it a long time ago, but only some of the recent investigations been more thorough to establish what exactly they represent. And so essentially by analyzing some of the rocks here, these scientists were able to establish a few things. And one of the first confirmations from the study is that at some point Earth was indeed a somewhat hot magma bowl. And when the first water emerged on the planet, it couldn't really exist as liquid water because it was just too hot. So most of it concentrated as water vapor, and this water vapor created these really large clouds across the planet. But obviously eventually all of this rain came down to Earth, and as the planet cooled down, the ocean formed as well. We actually still don't really have a good explanation to where exactly water came from, mostly because the explanations vary from between being delivered by comets, delivered by asteroids, or even coming from inside planet Earth and essentially emerging from within. And so today one of the biggest mysteries is still where exactly water really came from. It could also be, of course, all of the explanations together because water could have come from different sources. Either way though, at some point Earth very likely looked something like this, although it's not entirely certain if there was an ice shelf or not, but it was probably an extremely large water bowl. And it probably stayed this way for quite a while, possibly even over a billion years or maybe even a few billion years. Now that's obviously a question we can't really answer right now. What we can answer though is how exactly do scientists know that it probably looked something like this? So to try to discover this, the scientists actually studied 100 different samples from 100 different sites, and all of these rock samples had something similar in common. They basically had a very unique composition, and more specifically a ratio of oxygen 18 to oxygen 16. Now, like with every other element, oxygen also has various isotopes, and some isotopes are more common than others. Normally, oxygen 16 is the one that's present pretty much everywhere, but sometimes oxygen can also become oxygen 17 or 18, which are also stable isotopes and can survive for a very long time. And even though this one here is about 99.7% of all oxygen, this here can also be a significant amount. And any kind of a percentage deviation usually suggests to us that something may have happened to planet Earth in order for oxygen values to change. Or at least in order for the isotope values to change. And the reason why oxygen 16 is much more prevalent is actually because it's the main oxygen that's made inside stars. So a lot of stars that are initially made of hydrogen will eventually produce oxygen 16. Oxygen 18, however, requires this nitrogen to be made. So when nitrogen captures helium, it then turns into the much less prevalent molecule of oxygen 18. And so because of this, around different planets, this value is usually kind of relatively similar. However, when analyzing these rocks in northwest Australia, the scientists realized that there was actually a lot more oxygen 18 in those rocks compared to the rocks we have today. In other words, the ratio back then was much higher for oxygen 18 than it is today. But what does it have to do with water? Well, it turns out that on our planet, various types of soils that are usually rich in, for example, clay, often prefer to take up oxygen 18 as opposed to oxygen 16. So if there's a lot of soil around and if there's a lot of clay around, usually the oxygen 18 value goes down quite a lot. And so today we have much less oxygen 18 than we did back then. And so one of the better explanations for why oxygen 18 was much more prevalent 3.2 billion years ago is to imagine Earth as a water world with practically no soil and no continent sticking out. Essentially everything was underwater, and so there was nothing on the planet for the oxygen 18 molecule to be absorbed. And we're talking about absorption in the water, by the way, which is why what we're looking at here is essentially an ancient ocean floor, 3.2 billion years old specifically. And so as these rocks interacted with seawater, they essentially left this imprint of different values of oxygen, and this is what allowed the scientists to discover what Earth was like back then. They also simulated various conditions on Earth, trying to see if there was anything else that could cause similar effects. But the easiest and the best explanation was that the Earth was really a water world. And because geologists often use the oxygen 16 to 18 measurements to establish various changes on the planet that may have occurred in the past, this was a telltale sign that something on Earth was very different back then. And so it was very likely the appearance of continents and the shift from the water world to more of a land and water world that shifted the oxygen values. And as soon as Earth acquired plate tectonics and continents started to move around, that's probably when the oxygen 18 values dramatically dropped. But it's very likely that there were no continents at all as well, so something must have caused the continents to appear roughly around 3 billion years ago, or maybe a little bit earlier than that. Now, as I mentioned previously, they don't think the Earth was completely empty. There were probably some islands here and there, but they were not enough to influence the composition of oxygen on the planet. And by the way, all of this oxygen was already probably generated by various types of life living in the oceans. But because of this discovery, there are a lot of new questions now. First of all, this discovery implies that something may have actually caused the continents to appear later on. More specifically, some studies suggested that it was probably some sort of a very large collision, but this is something that we'll definitely need to investigate in a lot more detail now. At the same time, if this discovery is correct, then it's very likely that life did indeed start in the oceans, very likely close to the so-called hydrothermal vents. And this is actually one of the potential theories for where life started. At the same time, if the study is correct, this would also imply that life is very unlikely to start just on land. So basically, we can kind of skip looking for life on planets that do not have liquid water. Or at least the kind of life we have here on Earth, the organic multicellular life. If life indeed needed an ocean world to start, then we need to start looking for more of these objects that have both liquid water and hydrothermal vents. And we know that moons like Enceladus, for example, may have both, so the chances for finding life there are now actually a little bit higher than before. And the other big question is of course in regards to plate tectonics and what exactly happened to our planet in order for plate tectonics to actually occur. And this is a really important question because our planet's continents are responsible for maintaining its relatively constant climate and also for being able to recycle a lot of things. Without plate tectonics and without continents, our planet would very likely turn into something similar to a lava world once again, or at least look somewhat similar to Venus, which doesn't have plate tectonics. And so trying to confirm the validity of this study can definitely lead us to some of the more interesting and more important answers of the existence of life on our planet. And because there were several studies in the last few years that suggested that it's very likely that plate tectonics started because of an actual very large collision with our planet, this also kind of gives this theory a lot more credibility as well. So it's quite possible that a lot of things on Earth started as a result of major collisions, including plate tectonics and continents. Hello wonderful person, this is Anton, and in this video we're going to be talking about the possible resolution to the so-called faint young sun paradox. The idea that back in the days, billions of years ago, our sun was a lot cooler than it is today, which means that Earth should have been a lot colder and most likely would have been covered by ice entirely for billions of years. But we know this was not true. So how is it possible that with cooler sun, Earth could have still maintained its present temperatures? Or possibly even have temperatures that were much warmer than they are today. Now, interestingly, you can simulate all of this in Universe Sandbox. If you run a simulation of the aging of a typical star, and you'll notice that with time, both the luminosity and the surface temperature of a typical star starts increasing quite dramatically. At some point, if you actually run this for billions of years, you'll start noticing the dramatic changes in size. Now, it doesn't go as far as making an actual supergiant, but it does get bigger and bigger, as you can see. So in other words, as the typical G-type star, which is our sun, ages, it slowly increases in both size and temperature, and of course in luminosity, basically illuminating our planet with a lot more energy. Today we believe that when the solar system was created, our planet Earth was probably receiving about 20 to 30% less luminosity and thus energy. In other words, if you look at the modern solar system here, it's as if our sun was only about 70% as luminous as it is today. So here, if I actually change this right now, although it may not appear like anything changed, our sun is now a few hundred degrees cooler, and if you look at our planet Earth that orbits in the same location as it did originally, it will now start being covered with more and more ice until eventually it becomes really cold. So here we're actually not going to be getting as much heat anymore, and so the planet will slowly cool down, assuming we keep everything else the same, specifically the distance to the sun and other properties. Now I'm going to let this run for a few seconds while I explain to you what the modern science knows about the history of the solar system. So first of all, we don't think our planet changed its orbit too much. It may have been just a little bit closer because back then the sun was also a little bit more massive, so it had a little bit more gravity, and thus some of the planets were slightly closer, but not enough to influence the temperature that much. But this could be one of the potential explanations to this unusual paradox. Basically, how could you have liquid water on a planet if the sun was much cooler back then? This was originally proposed by the famous scientist Carl Sagan, but even today the explanation is not entirely clear, although the paper we're talking about today might present us with a pretty good, solid proof of what's happening here. So here's what our planet looks like now after only a few years, and it's getting colder and colder, and as you can see it's actually being covered by more and more ice. But so we have at least one more explanation. The sun could have had more mass and obviously produced a lot more energy, and so it's possible that the sun itself was actually emitting more energy simply because it was losing more mass. So even though its temperature and luminosity were kind of lower, basically it wasn't as bright as it is today, it was still emitting more energy overall because of the total mass loss. But this explanation is not really that well accepted. However, we have another explanation, and this one actually involves clouds. Clouds in general provide our planet with a bit of a reflectivity, so-called albedo effect. Today the reflectivity of Earth is about 33%, so basically the clouds reflect some of the light back into space, cooling down our planet. But it's possible that billions of years ago there were much less clouds, decreasing the total albedo. And we can even simulate this here in Universe Sandbox by decreasing albedo directly, which will almost instantly start warming up the planet. So less clouds means less reflectivity, and thus the planet becomes warmer. But this explanation doesn't really have a lot of proof, it's just an assumption. It's very difficult for us to establish how many clouds there really were. We know that clouds do actually form more common when there's more cosmic rays, for example, but we don't really know how many more clouds would form, and also we currently can't really model or predict how many clouds used to exist around the planet back then. But the most well-accepted explanation is a much better explanation that is also related to today's paper. And the explanation is of course greenhouse gases. Now we know that some of the more potent gases like methane and water could have been responsible for certain warming effects, like for example after a typical asteroid collision. But the gas we're going to be talking about is of course CO2. And specifically, based on this study, where they analyzed the actual samples from 2.7 billion years ago, the scientists were able to establish that the carbon dioxide levels of our planet were dramatically higher. And just to give you a comparison, today the levels of CO2 on the planet are roughly around 0.04% of the entire atmosphere. We have about 23% of oxygen, the vast majority is nitrogen, there's a lot of other gases like argon and so on, but CO2 is about 0.04%. And according to the scientists behind this paper, who studied ancient micrometeorites that came from right here in some of the regions of Australia where a lot of meteorites are usually preserved and kept for a very long time, they were able to establish that it's very likely the levels back then were roughly around 70% of the entire atmosphere. And it actually makes a lot of sense. It makes sense that back then there was almost no oxygen because no bacteria produced it yet. And it's also very likely that the ancient atmosphere of our planet was a very inhospitable place with a lot of really extreme conditions. And one of these extreme conditions is of course high levels of carbon dioxide. Now luckily for us, we can once again simulate these levels in Universe Sandbox, and having increased the value to 70%, this is what we kind of get. With the sun being only about 70% as luminous, the average temperature here is just a little bit lower than it is today. 11.5 degrees is about 4 degrees lower than the modern average temperature, and as you can see, the Earth for the most part has a relatively similar distribution of ice and liquid water as it does today. There's probably just a little bit more ice because the conditions here are just a little bit colder, but not enough for this to turn into an ice bowl. So in that sense, the scientists behind this paper are actually very likely correct in their assumption. The ultimate answer to the so-called faint young sun paradox is most likely a lot of CO2 in the atmosphere that allowed our planet to maintain these conditions. But so how exactly did they actually figure this out? Well, this is where it gets really interesting because we don't really have enough samples from back then to analyze the CO2 contents. Normally we use ice to discover this, but here we can't use ice because no ice is that old. Instead, the scientists use these tiny micrometeorites you see on the screen discovered in Australia, And a lot of these micrometeorites are very rich in iron. And the thing is, as they fall through the atmosphere of our planet, this iron starts interacting with oxygen inside the atmosphere and form this very specific compound known as wüstite, which sort of looks like this. Now, wüstite can only be formed in some of the more extreme conditions, such as rock that was hit by lightning or meteorites falling to the planet Earth. In other words, it's almost impossible for this compound to appear naturally on our planet without something major occurring. And when it comes to these micrometeorites, as they were falling through the atmosphere, the chemical reaction between the metal inside the meteorite and the oxygen present in the atmosphere of the planet started to create a lot of that material. But the thing is, to produce wüstite, the oxygen doesn't have to come from oxygen itself. It can also come from CO2. CO2 has oxygen in it. And so the scientists behind this paper, they actually simulated a model where the falling meteorites were falling through various types of atmosphere, including atmosphere that was very highly enriched in CO2, and then they compared the result of the model with the actual samples discovered in Australia. And it just so happens that the one that matched the most with the samples was the model that had about 70% of CO2 in the atmosphere of early Earth. So in other words, it's very likely that this is exactly how the Earth was able to maintain warm conditions on the surface, which also means that the actual atmosphere was very highly enriched in CO2 and possibly a few more other gases that we're not particularly certain about just now. Just to give you a comparison with Venus, today Venus has about 97% of CO2 by mass, but it also has a lot more atmospheric pressure. Back then, we don't think Earth was as high in atmospheric pressure, but right now we don't really know. Nevertheless, this discovery needs to be still confirmed, and once it is confirmed, if it's actually true, it means that we finally solved the decades-long paradox. We finally understand how Earth was able to maintain its warmth billions of years ago. And the thing is, figuring out how Earth looked back then when the life just started is really important for us, because by being able to see ancient Earth and then possibly comparing this to some of the other thousands of exoplanets we've discovered so far, we might be able to find one exoplanet that resembles ancient Earth quite a lot. And in that case, this could be our primary search target for finding extraterrestrial or alien life somewhere out there except for planet Earth. In other words, if we can find a planet that looks like what Earth looked like back then, this might mean that we might be able to find life there. And even though it might not be intelligent life, alien life of any kind would be pretty exciting for us to discover. And meanwhile, let's see what happens if all of these planets collide into one another and what's going to be created as a result. This is going to be a pretty interesting simulation, and it's very likely going to result in some sort of a major super Earth. Let's see what happens. And okay, I was wrong. Apparently everything got too hot and basically evaporated completely. We're now just stuck with a bunch of fragments flying through space. Well, that's unexpected. I kind of thought there would be a planet left.